This is 1985, number 39. And so if you look at the answers, what are they looking for? Where is it increasing? Where is it decreasing? And what tells us that? It's going to be the derivative. Positive derivative increasing, negative derivative decreasing. The next question we ask ourselves, where can it change? And it's only critical points. So we need to find critical points. And we need the derivative. And as you can see, it's going to be quotient rule. So it's going to be low d high minus high d low all over low squared. And I'm going to get 1 minus ln of x over x squared. There's my derivative. What are the critical points? Well, if the derivative is 0, I have a critical point. And when is a fraction equal to 0? When the numerator is 0. So 1 minus ln of x equals 0. Add ln of x to both sides. And then to get rid of ln, I e both sides. E and ln cancel. And x comes out to be e. All right, where else do we have critical points? Well, you would say when the derivative does not exist. And you might say when the denominator is 0, and you might conclude that is a critical point, but it actually is not. And here's the important part. You have to know what the ln of x looks like. ln of x looks like that. So this function here has the domain between 0 and infinity. So the domain is that. So 0 cannot be a critical point because it doesn't even exist on the original graph. If it doesn't exist, how can it be a critical point? So we could ignore that. So we only have one point of interest, E. And we need to find out what's happening around E. I'm going to pick 1 and E squared. And there's a reason why, and I will explain to you. So we need to find out what's happening with the derivative because we want to know increasing, decreasing, and that's all derivative. So let's plug in 1 here. What's ln of 1? 0. 1 minus 0 is 1. You plug a 1 there, you get 1. 1 over 1 is positive, so we get positive. So what do we know? Between 0 and e, the function is increasing because the derivative is always positive. Let's plug in e squared. You'll see why e squared is beautiful. If I put e squared, ln and e cancel, and I get 2. 1 minus 2 is negative 1 over e to the 4th. That's going to be negative. So I know it's decreasing after e. So increasing from 0. This is 0 because the domain starts at 0. That's infinity because it goes to infinity. So it's increasing from 0 to e, decreasing from e to infinity. So let's look. F is increasing greater than 0. False. F is increasing greater than 1. False, because here's our critical point. F is decreasing between 0 and 1. False. F is decreasing from 1 to e. Nope, because 0 to e. F is increasing for all x greater than e. Decreasing, sorry. Decreasing, yes. After e, the derivative is always negative, so the function is always decreasing after e. That is the answer.